Hello, welcome to my science experiment. Today we're going to be studying static electricity and the effects of the negative and positive electrons and their effects on water. So what I have set up, I'll introduce you real quick. This is my assistant Ryland. He's going to be watching mostly. And so what I have set up right here is I took a dropper, which used to look like this, and I just popped the end off, and I took a rubber glove and I just snipped off one of the fingers, and I cut a little hole on the top where I can fit the dropper end through. And once you have this piece, you can slide it onto your sink at home. And what I did is I took a rubber band and just put it around just to keep it on, get a little bit tighter. So basically what this is used for is we're going to create a stream of water. Now, what I'm going to do is just barely turn this on. That's a little much. And there we go. Just about right there should be good. So you see the stream? Okay. Okay. And right here I have just a plastic wand. This goes to my blender, but you can take any kind of piece of plastic. You can use a comb. A comb works really well. And what you're going to do with the comb is you're going to brush your hair through 10 times, and then you're going to do what I'm about to do. So what I'm going to do is just going to create a little bit of stack just using a towel. And I'm just going to run this back and forth on it. Okay, now what I'm doing right here is I'm just creating a negative charge on the wand. Now, you see what this, we're basically separating all the negatives out onto this conductor. Now, when I put it up to the water, and watch closely here. Come in a little closer, okay? So watch what happens with the, can you see the water? Oh. I didn't do it right. Let's see, let me pull this up. Might be because it's in my hand, but what you can also do is rub it on your pant leg like this. Here we go. There you go. Can you see the water bending? Can you see that? I'll even do it this way. Not running out of charge. You can see moving the thing. Let me try a little more. You don't want to necessarily, you definitely don't want to touch it. Once you touch it, it can take away your charge. So basically what's happening is the negative charge on the wand is taking the positive electrons that are in the water, and what it's doing is actually pulling the water towards the wand, therefore causing the stream to bow, as you saw. Did you pick that up pretty good, the bowing of the water? So you can see how it just as I move closer. Another way we can see this is I have over here some toilet paper. I took some toilet paper and I cut it up real fine, just ripped it up into really small pieces. You gotta make sure you put it in real small pieces or it's not gonna work right. Now what we'll do is just rub it on my pant leg here, and we'll hold it right over that. You can see the toilet paper is just sucked right up onto that. See, and another example of most of you kids will see is when you go down a slide, your hair will stick up, or actually a very big example would be this is kind of an extreme example, but lightning is a big example of static electricity, where in the clouds the particles are rubbing together and creating static electricity, kind of like I'm doing right here. And that electric charge will actually create the bolt. And if you go on the slide and you touch somebody, you'll easily shock them. That's a transfer of the energy. When you have a very imbalanced, you have all the negative charges or all the positive charges to one side, and they're basically finding a conductor, a source to go to and match up. So that's basically what we're going to be looking at. And so what you guys want to do is just go home and experiment with this a little bit, or I assume you are home right now. Experiment with this a little bit, test out, see if the hot water changes compared to cold water. Test a couple of different, try to come up with a hypothesis that you can test and bring back a paper into class, just write about your experience. And what are you doing, man? And we will go over it more in class. Thank you very much.